Okay, I wanted to show you, um, hopefully this will help with the naming. So you had to repeat or to print off this worksheet. It had chemical formula, and you're required to do the name. And then the other sheet was you have the name, and then you have to come up with a chemical formula. I thought maybe if I showed you a video of how you can set up to be 100% successful on naming, um, might help you out. So the most important thing is that you have these resources available to you. Naming is like a puzzle, and you recognize some of the pieces of it, and then you have to put them together. Now, recognizing the pieces is probably the most challenging task of this. So what do you have to have available to you? Have your periodic table with all your oxidation states, the ions that get made, and also have close by the sheet I had you print out last week. And this is the polyatomic ions. There's the anions, the with one negative charge, two negative charge, and then on the back is the three negative charge. And then I've added the only one positive, the cation is the ammonium ion. So it's the language. Like if I look through, I see acetate, like there's some pretty big names. I'm really, and honestly, not going to delve into these really complicated ones, but you might see a word that's got fluorate in it, or acetate in it, or chromate in it, or phosphate in it. So those are the kind of the checklist. You always want to go back and say, hey, wait a minute, is this formula or this name in the exercise that I'm doing? So you have these two sheets close by. So let's go through and let's show this. Remember, it's like a puzzle, and you got to think ions. So if I look at this, I've got my first one is Na2CO3. Okay, I recognize right off, and of course they start. This is classic. Polyatomics, you'll see, is just always asked. So I see Na and I go, what the heck is Na? Well, I go to my periodic table, and hopefully you're recognizing that I'm talking about sodium. So I know I have a sodium, and I also know the sodium has a one positive charge. That's not so important when you're going from um, formula to name. Okay, so I have a sodium, so I write the word sodium. And then I see this thing, I've got a carbon and an oxygen. Well, we talked about binary naming where there's two elements. Well, now I've got a sodium ion, or a sodium element atom, carbon atom, and an oxygen atoms. So right off, this is like, oh, there's something special about that. It's a polyatomic. So I look for something that's CO3. Okay, so I have to go to this sheet, and I'm looking for CO3. You just start going through the sheet. See how it's just you're solving a problem. So I'm looking for CO3. Oh, there I see it. CO3. Now it's showing the ion charge, if you can see that. CO3, and it's showing the ion charge. And again, I don't need to worry too much about that when I'm working with these, when I'm going from the formula to the name. I really just need to tell the story of what's here. There's sodium and there's CO3, which is carbonate. So I recall that the name stays the same for polyatomics, and the metal name, because it comes first, stays the same. So it becomes sodium carbonate. Okay. If I look at the next one, NaOH, I see the same idea. I see an Na. Well, I just did sodium, so I know that's sodium. And I see an OH. I got two atoms that are bonded together here, and that's polyatomic. And then I'm going to look now. I'm going to say, oh, there I see it. It's right there, OH, and it's called the hydroxide ion. Now, you don't say hydroxide ion is when it's by itself. When you put it bonded to a sodium, you don't include the ion anymore because it isn't an ion anymore. It gets balanced. The ions get balanced with the sodium. So this becomes sodium hydroxide. Here we go. We got MgBr with a subscript 2. There's two of them. If I was to draw a picture of that, That's what it looks like as a molecule bonded together, MgBr2. That's a little bit better. Okay, so I've got, oh, here I have a simple, believe it or not, this is a simple binary one where there's one atom or one symbol and a second symbol. And so there's none of this polyatomic thing, business going on. So I go now to my naming that we reviewed about this is a metal. And if I check on bromine, if you need to be sure, magnesium's a metal, it's over, magnesium, it's a metal, it's over on this side of the periodic table. I colored those in highlight blue. Bromine is a non-metal over here. It's a non-metal. It's on the right-hand side. So we're talking about an ionic bond being made between a metal and a non-metal. So I do my metal name, magnesium, and then the second name is bromine, but I change the ending to ide, bromide. Okay, so then we have another one, KClFeCl2. Okay, now I'm going to show you another one here. I'm just going to skip that one and go to this one. So I recognize this is this binary idea. I'm not seeing a polyatomic. Okay, great. So that means I don't need to check in the sheet. Okay, so now I'm looking at iron. I want to find iron on my periodic table. Make sure it's a metal. Oh, where is it? Where is it? Where is it? Ah, there's iron. Oh, okay. I've got a situation where I have iron 2 positive and iron 3 positive. This is this one that uses the Roman numerals, and I need to figure out which one it is. So I've got iron, and I'm not sure which one it is because my options are that it's 2 or 3. And I've got chlorine. That's a Cl. It's chlorine right there. And I change the ending to ide, chloride. But I have 2 of them. Now, chlorines have a 1 negative charge. So this is where you can, in this case, when you have multivalence, you can then do the showing the ions. Sorry, 1 minus. And it says there are 2 of them. So because there are 2, I draw my picture here, Fe. Okay, so there's FeCl2. That's what it actually looks like. I like drawing particle pictures. I know that there's a 1 minus charge on each of those chlorines. How do I know that? Because I went to my periodic table and it tells me that they gain electrons, they gain 1 electron, so they become a 1 negative charge. So each chlorine atom becomes a 1 negative charge. So what must my iron be in order to balance 2 negative charges? It must be, if I look at my iron, is it the 2, whoops, is it the 2 plus or the 3 positive, sorry, the 2 positive or 3 positive? It must be the 2 positive. That's the only way it can cancel those out. So that means I put a Roman numeral 2 to say it's iron 2 chloride. Okay, so that's the way you do work with your worksheet, your periodic table, polyatomic ion worksheet. I want you to try some of these now, and I can come back to them, and or you can email me or come to Teams, and I can help you out more with the naming. Then on the next part, we're looking at doing, we've got the name given, and now we have to create the formula. So let's just pick this one right here. Let's just look at 25, which is calcium phosphate. Okay, so I recognize calcium, and if I'm not sure, I just go to my periodic table and I look through and I go, oh, there's calcium. So now I'm doing formula, so I have to use the symbol, capital C, little a for my calcium. And then I come to something called phosphate. Well, it's not an ide and phosphate. Okay, is there a phosphate No, that's phosphorus, which would become phosphide. Okay, well, that didn't work. And again, I'm just showing you. I mean, I know what it actually is, but I want to show you how you can go through and feel the confidence in being able to answer these questions. So now I'm looking for, oh, wait a minute. I'm seeing phosphate, but that's not right. That's dihydrogen phosphate. So let's keep looking. Let's keep looking, looking through the names. Oh, there's a phosphate, but that's a hydrogen phosphate. Okay, maybe it's this one. There it is, the phosphate ion. So it's a PO4 3 negative. PO4 3 negative. Now, when you're doing the names to formula, always you want to do the ions. With these guys, you needed to show the ions when you were doing multivalent ones. Okay. You could just show the ions all the time if you wanted to make it easy on yourself. I have to go back and look at what my ion is for calcium, which I haven't written, but I actually know because it's in the alkaline earth metal. They're all 2 positive. So I'm going to write a 2 positive, and this is where the crossover rule comes into play. You have to bracket that so it becomes whoops, I didn't write that very well. Ca3PO4 2. Okay, so that was a pretty busy one. So there's the formula for calcium phosphate. Okay, I'm going to stop there because I want to see how you do the on your own. And again, I can help you out if you need some assistance on this. If not, I want you to complete all those questions. The more you do, the better you'll be at it.